Yes, I'll send. I will upload in YouTube and send to you. Okay, like that is it?
Okay, thank you.
Okay, okay. Thank you. Welcome. Okay. So, yeah, that is the idea basically here. Mm. So let me tell you one more example that you have that. So let we have a line. So now tell me. So if I take a point A and let's say take the point B and here take the point C, then the sometime the straight line we write the curly letter, so like that. Hmm. Okay, or you can say the script letter, right? The L or C, like that. So this straight line, can you give me two different name for this straight line that I have put here, the green color?
Yeah,
Tell me.
yeah.
Okay.
So it could be line, is that an L on
Yeah.
the right side?
Yes, on the right side the line L I put here. I take
Okay,
3 point.
okay.
Hmm. Yes, please.
So there's line AB, BA,
Line AB and
BA.
BA. Very good, very good. Okay, two name. You can use also C and B point. You have to select 2 point. Now, can you tell me two line segment that contain on this straight line? I mean, here on the line you have two line segment.
I'm sorry, could you repeat the question?
I mean, can you tell me two line segment that we get from this straight line using the point? Line segment. Can you give me the name of two line segment from here?
Um,
Yes.
from line
L.
ACB.
Yeah, from this line, the L line, script L line, the green line.
Oh, okay.
Yes. So
Um,
yeah,
yeah, I don't know.
recall the line segment mean a finite part of it. So we have 3 point A, B, C. We could take from A to B. So we could take A to B, that line segment. We could take B to C, that line segment. We could take A to C, this line segment, right?
Um, yeah,
Yeah, that actually I want. Did you understand now?
yeah, I do, yes.
Okay. The same thing AB, you can think BA, right? I'm not writing here, so not putting this. So basically it is line segment mean always you understand it is a finite part of a straight line. So that actually determined by writing down two end point of the line segment. So for example, if you want to take this from the distance or length from A to B, you have to write like this, A to B, then in the head or top you can put a line segment notation. Okay, Mohammed, it depends how the what kind of question they asking you. So for example, I asked you here, we have a straight line L, I mean the line L, script line L, and we took 3 point A, B, C. I provide you in the question paper, let's say, and asked you write down three line segment from this, the situation. So then you can say, okay,
Yeah,
AB line segment, right, Mama?
yes.
BC line segment, we can take AC line segment. Did your teacher ask this kind of question?
No,
Little bit different.
yeah,
Okay, all right.
was one question I didn't understand. It was a plain question. So the question was that what is another name for plane S? So
Oh,
it would show a picture of a plane, like one going sideways and the other one going up and down.
hmm.
And the top plane was called plane S, and I didn't understand what it was talking about. It was saying name another plane, name another name for plane S.
All right, all right. I got it. I got it. I understood. Okay, I'll do that kind of question. All right. So now see, look at the box. Okay, Muhammad, this box, can you see? I put here the box.
Yeah, I see
Okay,
the
in the
box.
top, in the this side. Okay,
Yeah, I see it.
yes. One thing, Muhammad, observe, line segment has a finite length, right? The length of line
Yeah.
segment is finite. You can measure using the ruler, right?
Yeah.
You put the ruler on it. I think this kind of thing, geometry, you call ruler, right? That you have this kind of thing. Have you seen this? Here you have small, 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 small,
Yeah,
and
yeah,
big.
yeah, I've seen rulers before, yes.
Yeah. What you call them? Ruler?
Yeah, we call it rulers or scales.
Scales. Okay. So this rulers or scale you take and put on the line segment. So end point you put it here, and then you maybe up to this. So I don't know, up to this, and you count up to this, right? Basically this part from here to here, the length you say, the maybe if you use the centimeter scale, then you call 5 centimeter, 2 centimeter, like that, right?
Yeah.
Okay, that way you can measure the, basically the length of any line segment. Yes. So now go to this box. If you see here, this box, you know, how many line segment I have drawn here? Can you tell me how many line segment you have here for this
Uh,
box? Look at
how
the
many line segments? Oh,
top surface.
there.
Look at the top part. How many A to B you have? AB line segment, right?
Yeah,
And BC
there.
line segment, yes. Then CD, AD. Yes, tell me. Yes. Then any other?
Um,
Yes.
other ones in the bottom, like EF and FE.
EF line segment, yes. And FG. Oh, sorry. I have to put here line segment, not as EF, FG, and GH, and EH. This line segment. Also, we miss something like the vertical segment, right? BF, right? And
Yeah,
GC, yes. And HD and AE. These are the line segment that we have for this box, right? Total. In the picture, we can see. Hmm.
yeah.
Right. All right. All right. Okay. Very good. So now, uh, you know, so now let me little bit talk about the ray. I think ray and opposite ray is clear. Should I go through again those ray and opposite ray?
Um, I got it.
Okay. Should I tell you again and little example on that base? So I think I need to tell you ray and opposite ray. Let me see now. Recalling everything will be recorded here, so it will be better for you, right?
Okay. Yeah.
Yes. So the ray. So any question, Muhammad, about the previous, the part that we have done here? Point,
No, I don't
line.
have any questions. No, I understand.
Okay.
I understand clearly now.
Okay. Okay. So ray mean basically it is one dimension, but it has only one. You can extend to only one direction. Okay. So it is a part of. Firstly, it is part of line. So it has one dimension, and then it can be extend. It extends infinitely in one direction. In one direction. So here the important thing is direction. Which direction you are, extending. Okay.
Yeah.
Yes. So for example, so it will start from a point. So you so let me tell here example. So let's say we have this kind of thing, and let's say this is the starting point of the ray, and let's say it extend this direction. We put here a arrows notation. Okay. So this means we want to say we extend to the the right hand side of the point A. So now if you take another name B here, or let's say C, another point. So then the how you name? You named by, you have to first put the starting point A, and you extending to the direction B, you can put it A to B, or you can put A to C. The same thing, okay?
Yeah.
But B to C, this not work. Got it?
Yeah.
B to C mean, yes, you understand from here to here, right? B to C mean this direction. This is B to C. So different thing, right? Two line segments are different because they starting from the different point. Yes. So the important thing that the starting point will be always same for the ray, right? When you named.
Yeah.
Okay, all right. So let me ask you a question. So let's say you have a segment here. It is, let's say, A point here, and let me put here R point here. Let's say put M point. Let's say X point. Can you give me three different name of this array?
Okay. So there is A Ray AR,
AR. Okay.
RA.
No, no array.
Oh,
Array
sorry,
mean,
sorry. AR. There's AM.
yes. You have to always take the starting point first. Then the point in a point, in the direction where you can extend. Yeah. And then
AM.
AX.
AM.
Yes, very good. AX. This way, if you have more point, then you can give the more name. Understand, Muhammad? Is it clear?
Yeah, it is.
Okay. All right. Now we define the new concept. So for the ray, the direction is important, right? The direction, in which direction you extend, and starting point when you give the name. Now the next is opposite ray. So if you take the opposite ray, so here it is. So opposite ray, how defined? Opposite ray mean you have pair of ray. So this is pair of ray, pair of ray, share the same common endpoint. Okay, share the same endpoint. So there, so this, for the ray, this kind of point we call the starting point. People call the end point. Okay. So if two rays start from the same, uh, end points and having the opposite direction and extend, so extend in opposite. Sometime ray necessary to understand, uh, geometry direction. So how it's look like? So you have here the point, right? Let's say I took the point O, and you have this direction a ray, and just opposite direction you take another ray. So I have used two ray. So both ray lie on the same line, right, Muhammad? Both ray lie on the same line, right? But the
Yeah.
direction are opposite. Yes, they're starting from the same endpoint. So let's say here you put A, and if you have here B point, then these two ray OA and OB, these 2 points are opposite. So whenever they asked opposite ray, this means you understand there are two ray starting from the same endpoint, and they are opposite direction. Both have each other. So opposite rays. This is the idea.
Got it.
Okay. Huh. Yes. Any question about this? The definition is clear.
Yeah, it is.
Okay. Now let me tell you a application of ray in the real world. So then you understand application of concept of ray. Sometime we need the application of the concept of ray in the local, life. So how it is? Basically, let's say you have a road. Okay.
Yeah.
So let's say the road. I'm assuming the road is straight line. So let's say road will always start from a point, right? I don't know, maybe some house you have here, right? I'm trying to draw it so little bit. So this is the house, right? Okay.
Yeah.
All right. So and let's say here, the road, let's say starting from this point, and the road go to this direction. So let's say the road go to this direction. So then your starting point, let's say O point, then this is the A point. Suppose in the A point you have the school, right?
Yeah.
Yeah. And then you can say that so when we use the road, yeah, the road, you say starting point A, the ending point, starting point O, ending point A. So like this. So this means you try to understand. Suppose you are talking with your friend. So you and your friend and talk with each other, right? Like that situation. And let's say this is you and your friend, and he asked a question. Let's say uh, you are standing at your home, and you explaining your friend that you will move to the school. So then you will explaining like this. We use the road OA in the notebook. If you write like that OA, then you put a ray, assuming that your friend has the idea of concept of ray. Then he understand, okay, the ray move, you know towards the school, and it is not stop at the point A. It has more part in the direction of the school, right? Just I'm telling you, this kind of concept we have to use sometime, right, Muhammad?
Yeah.
Okay, all right, fine. So now let me go to the next concept, that the plane. Okay, little bit about the plane. So here it is, that the plane. Okay, one thing I forget to tell you, you will call 2 3 points are collinear if they lies on the same straight line, or you can find a straight line that contain those points, right?
Yeah.
Yeah, the collinear concept is very important, right? So
Yeah.
yeah, so a collection of points are collinear if you know we can find a straight line containing those point, or we can draw a straight line. That is the idea. So they will provide you some points and ask they are collinear or not, right? Okay.
Yes.
Yeah, if you look at the box, let me go to the box. Are the point A, B, C collinear, Muhammad? A, B, C point collinear? A, B, and C.
I Yeah, they are collinear.
Can you draw a straight line that contain these 3 point A, B, C? Is it possible?
Oh wait, no, no, sorry. Are you talking about the box?
Yeah, in the box. So let me put here.
No, they are not collinear.
Yes. Okay. So let me. You have the situation A here, and you have this equation B here, and point C you are taking here. Are they collinear? No, right?
No, they're not.
Yes, A, B, because you cannot find a straight line, or you cannot draw a straight line on the same plane where A, B, C lie, such that the straight line contain those 3 points. So A, B, C are not collinear. Yes. So yeah, fine. Now, it is important that if you take any 2 point, then they are always collinear, right?
Yes.
So yeah, that is important here. So that any 2 point are collinear. 2 points are collinear. Yeah, right. So now, yeah, that is the idea of collinearity. You have some points where you are working, you are doing geometry, and you want to say they are collinear or not. How you decide? You try to find a straight line that contain those 3 points. Okay, Mohammed, fine, clear. That is necessary.
Yes.
Okay. Now, yes, the idea of the plane. Then I will send you a new link. Then we do the angle, about angle. Okay.
Okay.
Okay. Let me tell you about the plane. Plane mean basically, see, you have to little bit imagine. Plane mean what? You have to look at the plane, whatever you have. For example, you can take the wall. So if you look at the wall, right, that is a plane, right?
Yes.
And 1 second. So uh, 1 second, 1 second. So right, uh, they asked a question from the plane, right?
Yes.
Yeah, right. So see, now that we see how we can construct a plane. So plane mean it's something like that, right? Right.
Um,
This kind of thing.
yeah,
Yes. Now the question, what is the minimum condition need, or how many minimum condition need, I mean minimum point necessary to draw a unique plane, right?
yeah,
3 points. See, so to draw a straight line, how many point need? Two, right? If I give you
yeah,
a point A, and through A you can draw infinitely many line. Now if I fixed one point B, then there is a unique line content, passing through that 2 point. Okay.
yeah,
Right. So to draw a line, we need minimum 2 points. Okay. Now, to draw a plane, how many points we need? Especially, 3 points we need. You have given A, B points here, and then take another point that not collinear with this. So here you can take, right? Then, these 3 points will determine a plane. So how we can do? So AB, you can join by a line like this, right?
yeah,
Then that line you can move, you know, you can sweep, right?
yeah,
But you can if you take a straight line, imagine Mohammed, that if you take a straight line, and if I asked you sweep it, you can sweep it in any direction, right? Okay. But if I fixed a point in the space, then, and I told you just sweep in the direction of the point, then you get a plane like this. So this way, here you straight line you move, and here move like that. Did you understand the logic that I'm saying?
yes,
All right. So to determine a plane, we need minimum 3 points. So we can name plane by using 3 points. On the plane, we need 3 points to name it. So we can name like this. This plane, if we call M, then the plane we name by plane using 3 point A, B, C, or we can name it by plane A, C, B, whatever, 3 point we have to take from the plane and we give this way, right? And plane, one second, one second, one second, Mohammed.
Okay.
Can I send you a new link? Then we start again.
Yeah, yeah.
Okay, please, I'm sending.
Okay, thank you. Should
Thank
I
you.
leave this meeting?
Yeah, please leave that. I sending new link.
Okay.
Okay. Yes.